Let's go ahead and take a look at compressions and stretches. We're going to be using the graph of y equals the absolute value of x as our parent function. And remember, this is in the form y equals f of x. And we want to take a look at what happens when we're working with this absolute value of x function. What happens when we multiply it by the number 2 out in front? Right? And it could be any value that's out here in front of this absolute value of x function. So let's go ahead and rewrite this a little bit as y equals a times f of x. And we're going to be looking at the case here where our a value is something larger than 1, right? Which is the case that we're looking at, since we have a 2 out in front of our absolute value function. So this is going to be producing a vertical stretch. And let's go ahead and pick a number here that's on our graph. We want to pick a point that's on our original function, which is our parent function, y equals the absolute value of x. And let's go ahead and use the point, this is the point 33. And when we perform this vertical stretch by 2, we want to take a look at what happens to that point. Well, if we're stretching something vertically, we're making it taller, right? That's going to be impacting our y values. And we're going to go ahead and take the y value and we're going to be multiplying it by 2. Right, so if I look at the y value here, I've got 3 as my y value. So when we perform this vertical stretch, our new point on the new graph is going to become the point 3, 6, right? It was this y value that got multiplied by 2 to give us the 6. And if we take a look at that point, let's go ahead and call this one point P on the original function. Right? Our new point is up here at the point 3, 6. So let's go ahead and call this one P prime. And that's going to happen to every point on our original function, right? When we have a vertical stretch by 2, each of those y values is going to be multiplied by 2. Let's go ahead and take a look at the one we have for part C. This time we've got the graph of y equals 1/2 times the absolute value of x. Right? This is still in the same format, y equals a times our f of x, which is our function that we're working with. Only this time our a value here, we're going to be looking at the case where it's between 0 and 1. And in this case, it's going to produce some type of vertical compression. So think of it as you're going to be shrinking your graph height-wise, right? It's still going to impact your y values. And let's go ahead and take a look at that same point. Actually, let's use a different one. Let's go ahead and use the point 44 on this one. Right, the point 44 is on our original graph, which is the one that's graphed in red. Let's go ahead and call this one point Q for right now. And if we are performing some type of vertical compression by 1/2, right, we're going to be taking that y value times 1/2. Right, so we're looking at this 4, multiplying it by 1/2, and that's going to give us a new point. We're going to get the point 42. So we'll go ahead and call this Q prime. Right, and that's going to be on our new graph. Here's our point 42, which is on the graph of y equals 1/2 times the absolute value of x. Right, so anytime that value out in front is a number between 0 and 1, it can be written as a fraction or it can be written as a decimal, right? That's going to produce some type of vertical compression to our graph. It's going to shrink it height-wise. If we're looking at an a value that's bigger than 1, again, it can be a whole number, it can be a decimal, or it can be a fraction. As long as that a value out in front is bigger than 1, that's going to produce some type of vertical stretch or make our graph taller.